All right, I want to continue going over that test review. I just could not keep the video as long as I wanted to. So picking up with number 14 where I left off, what are the x-intercepts of the function? We know x-intercepts are the same as solutions, so if we wanted to, we have the factors, we could go ahead and set those each equal to 0 and we could solve for x. We'd have 0, and if this one, if we add 8 to both sides, we get x equals 8. We could have also went to Desmos and typed that in. So let's say I type in what's after equals. I don't have to type in the f of x. So x times x minus 8. Touches x at 0 and it touches x at 8. That verifies what the zeros are. In number 15, it asks how many real zeros does the function have? So that means, can I factor it, and how many factors can I set equal to 0 and get? So a couple of things you could do. So if you can't factor it, that's when you use quadratic formula, and if you get i's, that means those are imaginary zeros. The easiest way to figure out how many real zeros does the function have would either be to find them or to graph it. So I'm going to show you by graphing what you would be looking for. So I would be graphing this, x squared minus 5x plus 4. So when I graph that, it touches x twice. That means it has 2 real zeros. Let's say that I make this into something else. If I make that into a minus 4, that still works. Let me try to make something that's not going to work. Right there. Doesn't touch x. That means that it has imaginary zeros. Those are the ones you'd have to find using quadratic formula. So back to the one that we actually were dealing with, it touched x twice, so it has 2 real zeros. In number 16, it says describe the end behavior as x approaches negative infinity. So I'm going to describe the end behavior without graphing it, and then you could verify by graphing. So if I want to describe the end behavior without actually graphing it, I need to think about the highest exponent and the leading coefficient. Well, leading coefficient connected is positive. The highest exponent is 5, which is an odd number. Positive and odd, if you go back to the chart that we had in our notes from a couple days ago, you'll see what it does. Or you can also remember positive odd is like positive slope where the left end goes down, the right end goes up. So the question says as x approaches negative infinity, what does y do? X always approaches negative infinity on the left side. So where's y pointing there? It's pointing down to negative. Let's say that you cannot, that chart was a little harder for you to visualize, so you wanted to actually graph it. So let's go back to Desmos and I'll type that graph in where we had x to the 5th. And then we had plus 3x squared plus 6. All right, so notice the left side is going down. Y values are getting smaller. So that's how you can see the graph to help you verify that answer. Going on to some more review for our test. If we look at problem 17, it says, what are the y-intercepts of the function? A couple ways you could find this. So you could find it by graphing, of course, but we could also think about, if something's touching the y-axis, so if I'm touching the y-axis right here, it didn't move left or right, meaning the x-coordinate is always 0. So if I want to find y-intercepts, I can make x 0 and solve for y. So if I make x 0 and solve for y, I would have y equals 0 squared plus 7, so I'd get y equals 7. That means the y-intercept is at 7. It's at 0, 7. And if you want to verify, go to Desmos and type in that x squared plus 7, and you'll see the graph touches y at 7. So I'm going to type x squared plus 7. The graph touches y right there at 7. That's the y-intercept. And going back to the questions we have for review, in number 18 it says, based on the graph, which 0 or zeros of the polynomial function occur an odd number of times? Well, odd number of times remembers when it goes straight through x at that 0. So right here at -3, it bounces away. That's even. Right here at 0, it's going straight through. That's odd. Here at 5, going straight through, that's also odd. So at 0 and at 5, those are odd multiplicity. Those occur an odd number of times. The last one, number 19, what is a factor of the polynomial graph? Remember, factor, you have to flip where it touches x. So if this touches x at -1, that means the factor is x plus 1. Right here, we touch x at 2, the factor is x minus 2. And last, we touch x at 5, the factor is x minus 5. So hopefully that helps you guys review. If you still have questions about anything,